Now we had a meeting a month ago or so, and what we have to decide is how we transfer the knowledge in this way, but also we protect the interest of the ITER members, because we are a public funded institution, and we have to ensure that the knowledge is transferred, but also in a fair way, so that the people that have paid for this knowledge get the return they should do, either through the private companies or through other ways. And this is something which we are actually discussing now. I think other thing that would be very important to discuss for the future is how we divide in terms of research. And I think this has been done in many fields, like pharmaceutical research and medical research, etc. How do we divide the academic part, which is kind of open knowledge, from the proprietary part of the private companies? How do we do open research and define that in a clear way so that we can work together? Because I think whatever is learned, if you have to access some regime in a tokamak, who pays for this tokamak, whether it's a public institution or a private institution, the plasma physics doesn't know. And so it is very important, in my view, for having a smooth collaboration is to define these boundaries clearly, because I see no reason. At the moment, this is not defined well, and I think this is causing some friction, which is, I don't think, necessary. And then just my final comment, since this session is mostly to younger people, I will express my personal feeling is that for me as a scientist, the thing that I like, I come from theoretical physics. So what I see very rewarding of fusion as a science is that you can do actually quite complex calculations. You can do things which are very deep physics, but at the end, first you can try them, because you don't have to wait for, some very, you have to go to energies of the beginning of the universe, and then you will die without knowing if what you say is right or wrong. So you can try it, and also what you try, if you're right, it has an impact, potential impact in humanity for the future. And I think this is something that we share, I think everybody here. We think fusion will work and will change our civilization. So frankly, I don't want to spoil the discussion, but I see no reason why, if I were in this field, I would not continue in it. Because, for me personally, I see we are not like Moses. We have crossed the desert. We see the promised land. I'm about to retire. We will retire before. And frankly, this is an opportunity that if somebody tell me today, would you take this field? I see why not. There is no reason why not, frankly.
Very good. Thank you very much. Ambrosio.
So as Richard said, Eurofusion, which I represent here, is the consortium that supports and coordinates research across Europe. Europe intended in a wide sense of the world, not only the European Union members. So it's a consortium of many institutions, but I say more importantly is of many individuals, many human beings, who have a very wide spectrum of competencies. In fact, our friends from the private sector come and do shopping with us often, and we are very happy and proud for that. And there's also a consortium in which the institutions that train these young generations are present and active, and we coordinate and foster that. And of course, this is the lifeblood of the fusion effort, which is intrinsically transgenerational. So we cannot do without that. And I hope you could become younger again, Alberto, because that would be really, really way to do it. So our R&D efforts are prioritized to address what's perceived to be the most urgent science and technological issues and the gaps that remain open. We use a variety of facilities from plasma and technology all over Europe, state-of-the-art simulations, but also we have a look, and I think fairly uniquely in the world, to something that's crucial, and Alberto just said that from the point of view of ITER, that is the integration of things. And that's possible when you have a full spectrum of competencies and a full spectrum of facilities and approaches. We, of course, now assembling ITER, and invaluable lessons are learned, are being learned, have been learned, and will be learned from ITER through all of these steps, all of the steps of the projects. So we try to contribute as best to ITER. At the same time, we look forward to the next step, which is a prototype fusion power plant, which we refer to as demo. And we develop the conceptual design for it in our teams. Demo will produce hundreds of megawatts of electrical power, and we'll do that with a self-sufficient tritium cycle. So that will take fusion out of the labs and into the economic world, demonstrating the performance and the integration of technologies that are key in a way that is prone to the development of power plants. All of us, therefore, recognize, when I say taking out of the lab into the industrial world, that means we all recognize that not only demo will be built by industry, we also need to be designed by industry. And that's the way for us to go together. So we need to combine the capabilities of industry, the entrepreneurial approach, agility, with the vision and the know-how of the public sector, at least so far, which is so wide across all our members. So we need a collaborative approach that involves joint leadership between research institutions and industrial partners, combining private and public IP, and procurement processes that are agile enough to move relatively swiftly. That means we need public-private partnerships. And these partnerships are needed not only to go to demo, but also to address the technological gaps that are on our way to demo. In other words, they're needed now. And that's what we're trying to push now. Gaps, we all sort of know them, include tritium blanket, breathing blankets, structural materials, aspects of the superconducting magnets, and so on. So these PPPs will be really the vehicle to develop capability and capacity in the supply chains for demo and for what comes after demo, of course, especially in the areas that are not stimulated necessarily by the ITER procurement, because there are also some of those areas. So we are optimizing our structure to address those challenges, including much more openness to innovation that maybe we had in the past, in order to work hand in hand with the private sector. So if I summarize the challenges we are facing, we need to reinforce the development and the retention of a diverse human capital. We need to strengthen and support to ITER to complete the assembly and to prepare scientific exploitation, adapting our R&D plans in line with the new baseline that was presented by Alberto, in fact. We need to capitalize and document all the lessons learned from ITER in a systematic way so that we can inject them step by step into the developments of the next demo program. And we need to advance, obviously, together, all together, towards demo, and at least our continent, but also together with industrial partners. So that's the only way to go forward. Thank you very much.
Thank you. Finally, Laurent.
Hello.
Yep.
Yeah, okay. I'm Laurent Mas. I'm an inertial confinement fusion physicist and group leader at Laser Plasma Physics Group. I work at the CEA, which is a French government institution specialized in atomic energy in a global sense. And I'm here to talk on behalf of GENEF, which is on the opposite of the fusion chain. So you have ITER and on the opposite. Yeah. We are super small, but it's a newborn startup aiming to obtain energy we generated by fusion using a classical direct drive inertial fusion scheme. And I will take a few seconds to talk about this new startup. So again, that's a newborn startup. And it was after the ignition achievements by NIF in laser, NIF recently. The laser branch of the company Thales, which is specialized in large system lasers, has decided to go after the fusion quest and wanted to build system to get ignition. So, but they are just specialized in lasers. So they ask people who are specialized in fusion, so like CEA, to help them. So there is a French initiative supported by the French government to help fusion company, new fusion company. So the newborn GENEF startup, which is actually today a free people company, it's not 800 people, is supported by the CNRS from France and the university, and with the support of CEA. It's interesting to see what's happening in Europe, because I think it's similar to what is happening in Germany, because the government of Germany is supporting a private company. So in France, we have kind of the equivalent. So it's nice to see this kind of startup built on both private and public funds. So I think it's quite inspiring. I'm glad to see that. So this private company, GenF, is a kind of a pre-stage, and we are really on the beginning of this first stage. So it's just starting. So the point I wanted to make about that is, so it's great. You have ICF fusion companies in Europe, one in Germany and one in France. So it's kind of new. So we are really small, little creature as compared to ITER, but it's nice to see that it's happening. So there's two points I would like to make. We have seen incredible breakthroughs those years with ignition on NIF and breakthroughs on JET and EAST. So it was really great for fusion as well for the whole world. But I think we have seen also this week that fusion to the energy plug, so fusion energy to the plug, is still a long way. Maybe it's not tomorrow. I don't know what you think, Alberto, but I think we still have time. So the point I want to make is that absolutely need to attract, train young scientists. We absolutely need young people working on this field. And plus, we need to have innovation. So we don't need to stay on old ideas. We need to have new ideas, new innovation, new startups, and new things to try, because otherwise we never get there, I think. There is another point I wanted to make. It's collaboration. People already said that, but I think it's important to collaborate because we are spending a lot of money on those things. So it's nice to collaborate and share things. And could be nice to collaborate between the two approaches, so inertial confinement fusion and magnetic confinement fusion. So there's 2 points where I think we should try to collaborate and see if we can do that. The first one is the tritium breeding, because it remains a major hurdle, and there is no operational functional tritium bridging, as I think so, material what's never tested so far. So we really need to work on that. That's the first thing. And the second thing is probably diagnostics, because we can share diagnostics. I think about Thomson scattering or things like that, maybe other things. So it will be nice to sit and see if we can work on this thing.
Great, thank you very much. Okay, so we're now, PowerPoint, lovely. We're now opening this up for debate. We did have, there were some themes that were suggested by the organizers, but it really is up to you as to what questions you want to ask. We did ask the panel to prepare some thoughts on, pathways, on the partnership questions, the career possibilities and wider benefits, but these are just some suggestions of themes. You are welcome to ask any questions you like. Maybe we need the lights up here. In the middle there, I think I saw first. Can we get the lights up in the room? Perfect, thank you.
Okay. Sorry. Hi, Richard.
Hi,
Long
how you
time
doing?
no see.
Yeah.
Daniel Intrinsic from the University of Illinois Urbana-Champaign. Some very interesting comments. I'm quite involved with a lot of the several private companies in America and in Europe, and I think Alberto and Laurent made some very interesting comments about sort of the public-private partnerships and that. And I'm going to potentially bite a few hands that feed me here, since they're sitting right next to me here. One big